Hello students, welcome back. So we are doing logarithms exercise 8D from ICSE book of class 9, isn't it? And we have completed till question number 5 in our previous videos, and today we'll start right from question number 6 onward. Okay, so let's begin. This is question number 6 from exercise 8D, logarithms. Okay, if a square plus b square equals to 23ab, so that log a plus b upon 5 equals to 1 upon 2 and within the bracket log a plus log b, isn't it? So this is the given condition. Okay, we are asked to prove this. So let's begin. Let us first use the given condition. Okay, so we need a plus b in the left hand side, isn't it? So we have a square plus b square. Now let us make this a square plus b square to a plus b. Okay, since we have a square plus b square equals to 23ab. This is given to us. Now we put the formula for a square plus b square. Okay, so what is the formula of a square plus b square? A square plus b square means a plus b whole square minus 2ab. Okay, we are trying to convert into a plus b, isn't it? So a square plus b square can be written as a plus b whole square minus 2ab equals to 23ab, or a plus b whole square equals to 23ab is in the right hand side. Now let us take minus 2ab to the right hand side. This becomes plus 2ab. Now a plus b equals to 23ab plus 2ab becomes 25ab, isn't it? So this square goes to the right hand side and becomes root. Okay, or a plus b equals to 25 root means root under 25 means 5, isn't it? 5 5s are 25. So root of 25 is 5. Now ab remains within the root. Okay, so a plus b equals to 5 into root ab. Now let us assume this is equation 1. Okay, we are going to use the value of a plus b, that is 5 into root ab here. Okay, now let us take the left hand side of the equation and prove the right hand side. So let's begin. LHS, left hand side equals to, we have log a plus b upon 5, isn't it? Log a plus b upon 5. This is what we have in the left hand side. So let us put the value of a plus b. Log a plus b means 5 into root ab from equation 1. A plus b means 5 into root ab. So instead of a plus b, I can write 5 into root ab upon this 5 is already there in the denominator. So this 5 and this 5 can be cancelled. So let me continue here. Log root under ab, this 5 and 5 is cancelled. We have log root under ab, isn't it? This equals to log ab whole to the power 1 upon 2, isn't it? Root under means 1 upon 2. Okay, equals to, this power can be brought in the front, isn't it? So 1 upon 2 log ab, this 1 upon 2 is brought in the front, so log ab equals to 1 upon 2 log ab means log a into b. So log a into b can be written as log a plus log b, isn't it? So log a plus log b is actually log a into b, that is log ab, isn't it? So this is what we have in the right hand side, equals to RHS, hence proved. Okay, so I hope you got this. Now let us do the next question. 7 of exercise 8D. So we have, if m equals to log 20 and n equals to log 25. These two are the given conditions. Okay, the value of m is log 20 and the value of n is log 25, and this equation is given to us. 2 log x minus 4 equals to 2m minus n. So from this equation we are asked to find the value of x. Okay, so let us do this question. This is the given equation, isn't it? So let us write the given equation again. Since 2 log x minus 4 equals to 2m minus n. This is the given equation, okay? Or you can write this as log x minus 4, this 2 goes to power, isn't it? X minus 4 whole square, this 2 is taken as power, equals to, let us put the value of m and n, okay? So 2, this 2 we write here 2, m means log 20, m means log 20, this is given to us, isn't it? Log 20 minus n, n means log 25, log 25, isn't it? So log x minus 4 whole square equals to log 20, this 2 goes to the power, okay? Log 20 square minus log 25, isn't it? So log x minus 4 whole square equals to log 20 square means 2 squared is 4, okay? 0 squared means double 0, single 0 squared means double 0, okay? 20 squared means 400, 20 is a 400. Now this minus log m minus log n minus log 25, isn't it? So minus means we bring down this 25, okay? So log m minus log n means log m by n. So 5 5s are 25, 5 8s are 40, 5 0s are 0, 5 1s are 5, 5 1s are 5, 6 7 8, so 30, 5 6s are 30, isn't it? So log x minus 4 whole square equals to log 16, isn't it? In the denominator we have 1, so no need to write that. Log 16, okay? So log x minus 4 whole square equals to log 16, isn't it? Now we leave log from both the sides, okay? We should not cancel log, log cannot be cancelled, we just leave log from both the sides. Now we write x minus 4 whole square equals to 16, leaving log from both the sides, x minus 4 whole square equals to 16. Now x minus 4, this square goes to the right hand side and becomes root under, isn't it? Or x minus 4 equals to root under 16, or x minus 4 equals to root under 16 means 4 4s are 16, isn't it? So root under 16 means 4, square root of 16 is 4, 4 4s are 16. So x equals to, this 4 is already in the right hand side, so let us take this minus 4 to the right hand side, becomes plus 4. Therefore x equals to 4 plus 4 is 8. So we were asked to find the value of x, and the value of x is 8, okay? I hope you got this. Now let us move on to the next question. Question number 8. Solve for x and y if x is greater than 0 and y is greater than 0. So we are asked to find the values of x and y, and the condition is x should be greater than 0 and y should be greater than 0. The value of x should be greater than 0 and the value of y should also be greater than 0. And the condition is log xy equals to log x upon y plus 2 log 2 equals to 2. Okay, this equals to 2, which means, let us understand like this, okay? If a equals to b equals to c, a equals to b equals to c means the values of a, b and c are equal, isn't it? Which means you can write a equals to c and b equals to c, isn't it? If a, b and c are equal to each other, we can write a equals to c and b equals to c. Okay, so that is exactly what we are going to do. Log xy equals to log x upon y plus 2 log 2 equals to 2 means log xy equals to 2 and this equals to 2. Okay, so first equation will be log xy equals to 2, log xy equals to 2, a equals to c, and b equals to c. Okay, so this equals to 2. And second equation is log x upon y plus 2 log 2 equals to 2. Okay, so these two are the given equations. We are asked to find the values of x and y, and x and y should be greater than 0. Okay, so let's do this. So let us convert this into exponential form. This is logarithmic equation, isn't it? Let us convert this into exponential form. Okay, so we don't have base here, means the base is 10. Base is 10, isn't it? If the base is not mentioned in logarithm, we should understand the base is always 10. So this base 10 we write here as it is. Now this 2 comes here as power, equals to this xy goes here. Okay, or xy equals to 10 square, means 10 tens are 100. So this is equation 1. Okay, xy equals to 100. Now from equation 2, let this be equation 2. Okay, so log xy or log x upon y, log x upon y, okay, not xy, x upon y, plus 2 log 2 means log 2 squared equals to 2, isn't it? This 2 goes to power here. So log x upon y plus log 2 square means log 4 equals to 2. 2 to the 4, isn't it? Or log, see here, log m plus log n, isn't it? Log m plus log n means log m into n equals to 2. 2 is in the right hand side. So let us convert this logarithmic equation to exponential form. Okay, here also we don't have base, so we consider the base to be 10, or 10 we write here as it is, base, this 2 comes here as power, equals to xy into 4 goes to the x upon y into 4 goes to the right hand side. Or let us bring this number to the, first let me write this like this. Okay, 10 squared is 100, this 4 comes down to the denominator, equals to x upon y, isn't it? Or 4 1s are 4, 4 2s are 8, 9 10 2, 4 5s are 20. X equals to y into 25, isn't it? Cross multiplication, y into 25 is 25y. So x equals to y into 25, 25y. So this is equation 2. So we have x equals to 25 into y, equation 2. So let us put the values of x in equation 1. Okay, putting the value of x from 2 in equation 1, putting the value of x in equation 1. Equation 1 we have x y equals to 100, x into y, x into y equals to 100. This is equation 1, isn't it? So the value of x is 25y. So instead of x I write 25y. X is 25y into this y is already there, equals to 100. Okay, so y into y is y squared equals to 100 is in the right hand side. Now let me take this 25 to the denominator by cross multiplication. 25 1s are 25, 25 4s are 100. Or y equals to, square goes to the right hand side and becomes root under 4. Or y equals to, let me continue here. Okay, y equals to root under 4 means 2 2s are 4, y equals to 2. So we found the value of y, isn't it? Now let me find the value of x. Okay, putting the value of y in equation 1 or equation 2, we can find the value of x. Putting the value of y in equation 2, x equals to 25y, isn't it? X equals to 25y, or x equals to 25 I write as it is. So y isn't it? X equals to 25, y, and y is 2, isn't it? So instead of y I write into 2. Therefore x equals to 2 into 25 is 50. 2 into 25 is 50. 2 5s are 10, 0, 2 2s are 4, plus 1 is 5, 50. Therefore x equals to 50 and y equals to 2, isn't it? Y equals to 2. So we were asked to find the value of x and y. The values of x and y are 50 and 2, which are both greater than 0, isn't it? So I hope you got this. Now let us move on to the next question. Question number 9. Find x if. This is question number 1 of 9 and this is question number 2 of 9. Okay. So question number 1. Log 625 to the base x equals to minus 4. So let us first copy this question. Since log 625 to the base x equals to minus 4. So this is a logarithmic equation, isn't it? And we should keep in mind the base of this log is x. Okay. The base is mentioned here. The base is not 10. If the base is not mentioned in any logarithm, we should understand the base is 10. But here the base is mentioned and the base is x. Okay. So this is a logarithmic equation. We are asked to find the value of x from this equation, isn't it? So how do we do that? We convert this logarithmic equation to exponential form and then we will find the value of x. Okay. So log 625 to the base x equals to minus 4. What we do is we convert this into exponential form, isn't it? So this is base is x, so we write x here. This minus 4 comes here as power, x to the power minus 4 equals to 625 goes to the right hand side, isn't it? Now you can see x to the power minus 4, the power of x is negative, isn't it? So if I bring down this x to the denominator, the power changes to positive. We have done this in laws of indices, isn't it? Chapter 7. If you have not watched that video, please find the playlist, okay, and do watch that. The rules of indices. X to the power minus 4, the power of this number is negative. So if we bring down this number to the denominator, the sign of the power changes to positive. Now this is 625, isn't it? Now we apply invertendo. Okay, invertendo means we bring this number from the denominator to the numerator, and here in the right hand side also we do the same thing. We bring the number from denominator to the numerator and numerator to denominator. Okay, just invertendo, invert. Okay, like we do squaring both the sides, cubing both the sides, multiplying by 2 by both the sides, multiplying by 2 both sides, dividing by 2 both sides, isn't it? So when we do both sides the same thing, the value of the equation does not change, isn't it? So let us apply invertendo both sides. X to the power 4 goes to the numerator and 1 comes down to the denominator. Okay, so here also 1 goes to the numerator and 625 comes down to the denominator. The value of this equation does not change when we do this. Okay, now every number has 1 in the denominator, isn't it? Every number has 1 in the denominator, so we need not write this 1. Now what we do is x equals to this power 4 goes to the right hand side and becomes 4th root of 1 upon 625, isn't it? 4th root. Okay, or x equals to, so root under 1 equals to 1, cube root of 1 equals to 1, 4th root of 1 equals to 1, 5th root of 1 equals to 1, x root of 1 equals to 1. What I mean to say is 1 to the power x equals to 1, 1 to the power y equals to 1, 1 to the power 100 equals to 1. Whatever be the power, 1 to the power 0 equals to 1. Okay, whatever be the power of 1, whatever be the power of 1, the 1 will remain 1. Okay, so 4th root applies to both the numerator and the denominator. So 4th root of 1 is 1, isn't it? Are you getting me? This 4th root applies to both the numerator and denominator. Fourth root of 1 is 1. Okay, so no need to write. Fourth root of 1 is 1. Fifth root of 1 is 1. Fourth root means 1 to the power 1 upon 4, isn't it? Equals to 1. So 6 to 5, fourth root. Fourth root of 6 to 5, isn't it? 6 to 5 means 25 into 25 is 65. 5 into 5, 25. 25 into 5 into 5. It's 65. Okay? 5 5 is 25. 25 5 is 1 to 5. 1 to 5. 5 is 65. So fourth root means we make fourth pairs. 4 pairs. 1, 2, 3, 4. Okay? And free from the root. I hope you are getting me. Now, x equals to 1 upon 1, 2, 3, 4 5s gets free from the root, and only 1 5 comes out of the root. Okay? Because fourth root, isn't it? So x equals to 1 upon 5. So this is the answer. If we convert this into decimal, how do we write? X to the power. So we write point and we can introduce a 0. Okay? So 5 1s are 5, 5 2s are 10. Are you getting me? So x equals to 0.2. Point means we can add a 0, 5 2s are 10. Okay? The value of x is 0.2. Now let us do question number 2. Log 5x minus 6 to the base x equals to 2. Let us rewrite this question. Log 5x minus 6 to the base x equals to 2. Now let us convert this to exponential form. X to the power, this square comes here, equals to this 5x minus 6. Okay? This x base remains here, this 2 comes here as power, this 5x minus 6 goes to the right hand side. Now let us bring everything to the left hand side. X square minus this plus 5x becomes minus 5x. When we bring to the left hand side, minus 6 becomes plus 6 equals to 0. Now let us factorize this. 6 1s are 6. There is 1 in front of x square. The coefficient of x square is 1, isn't it? 6 1s are 6. So 6 means 2 3s are 6, isn't it? That means x square minus 5x. We need minus 5x, isn't it? So 2 and 3. By using 2 and 3, we need to bring minus 5x. So minus 2x minus 3x plus 6 equal to 0. Or x, the common is x. X into x is x square minus x into 2 is 2x minus the common is 3. 3 into x is 3x. Minus into minus is plus. 3 2s are 6 equal to 0. Or x minus 2 common, x minus 2 and x minus 3 remains within the bracket. Okay, equals to 0. So the product of these two numbers gives us 0, isn't it? This and this when we multiply gives us 0. This means either x minus 2 equals to 0 or x minus 3 equals to 0. So if this equals to 0, then x equals to 2, or if this equals to 0, then x equals to 3. Therefore, we have two values of x, that is 2 or 3. Okay, so we were asked to find the values of x. The values of x are 2 or 3. There are two possibilities for the values of x, 2 or 3. Okay, question number 10. If p equals to log 20 and q equals to log 25. So these two are the given conditions. Find x if 2 log x plus 1 equals to 2p minus q. So this is the given equation. Okay, so from this equation we are asked to find the value of x, and the condition is p equals to log 20 and q equals to log 25. Okay, so let us rewrite this equation first. Okay, since 2 log x plus 1 equals to 2p minus q, isn't it? Or log x plus 1, this 2 we take to the power, this 2 can be taken to the power, okay, equals to 2, we write here as it is 2, this 2. P means log 20, okay, minus q means log 25, we put the value of p and q, okay, p means log 20, q means log 25. Now log x plus 1 whole square equals to log 20, this 2 we take to the power 20 square minus log 25, isn't it? So log x plus 1 whole square equals to log m minus log n, isn't it? So log m minus log n is log m upon n, isn't it? So 20 square is 400, 2 square is 4, single 0 square means double 0, divided by 25. Log m minus log n means log m upon n, okay? So 25 ones are 25, 25 16s are, isn't it? 25 16s are 400, okay? Or leaving log from both the sides. Now first let me write this, okay? Log x plus 1 whole square equals to log, we have 16, 1 is in the denominator, we need not write that, log 16, okay? Now leaving log from both the sides, log and log can be left. Now we have x plus 1 whole square equals to 16, isn't it? Or now x plus 1 we keep in the left hand side, we take this square to the right hand side, okay? X plus 1 equals to root under 16. X plus 1 we keep in the left hand side, we take this square to the right hand side. Or x plus 1 equals to root 16 means 4 4s are 16, isn't it? 4 square is 16, so square and root cancels out, so we have 4. Root under 16 means 4. Or x equals to 4 we have, so plus 1 we take to the right hand side becomes minus 1. Therefore x equals to 4 minus 1 is 3, okay? So we were asked to find the value of x, isn't it? And the value of x is 3. So I hope you got this. Okay, this was for today. Thank you so much. Stay connected and practice well. I'll upload the rest of the questions in the next video. Thank you.